we're going to look at the bit shift operator. Now, this operator allows us to double, quadruple, and halve numbers, for example, by shifting bits to the left or to the right. So let's see how this works by applying this to an example. So let's start off with a binary number. So we're going to do that. So we're going to have 1, 0, 0, 1, 0. So hopefully you can work out that that is 18 in denary. Now if we shift one bit to the left, so let's just do that. So now if we shift the whole thing one bit to the left, we get 1, 0, 0, 1, 0. And now we add another 0 on the right hand side here, so that's the least significant bit. What you'll find now is our value, so 32 plus 4 is now 36. And again, if we shift one bit to the left again, so we're going to end up with 1, 0, 0, 1, 0, 0. So again, we're adding on another 0 to the right hand side to the least significant bit. So now our value is 64 plus 8, which is 72. You've probably worked out now that there's a pattern emerging here. So every time we shift one bit to the left, we're actually doubling our value. Of course, we've chosen 18 as our number. It can apply to any number that we choose. So if we shift 18 one bit to the left, we get 36, and if we shift it again another bit to the left, we get 72, and so on. If we shift it again another bit, we'll get 144, and so that way we're able to double numbers and quadruple numbers and so on. So we've seen what happens to our number when we shift to the left. What happens if we shift to the right? So let's just do that with the same number again. So we've got 18 here. We start shifting to the right hand side, shifting to the right. We now have 1, 0, 0, 1. So what happens is this 0 has fallen off the end. So this value now is 9. If we shift again to the right, we end up with 1, 0, 0. So now our value is 4. So you can see what's happened there is our value has been truncated. This 1 has fallen off the end, and we now end up with 4. Of course, half of 9 is 4.5, but we can't represent a fraction in this instance, and so therefore we end up losing the fractional part of our number there. So what happens is when we do shift an odd number to the right, it actually gets rounded down and truncated. Let's examine the impact of applying the bit shift operator. So if we shift to the left 3 places, then that's the same as multiplying the number by 8. If we shift 2 places to the left, it's the same as multiplying by 4. And if we shift 1 place to the left, it's the same as multiplying by 2. Now if we shift to the right by 1 place, it's the same as dividing the number by 2. If we shift 2 places to the right, it's the same as dividing the number by 4. And if we shift 3 places to the right, it's the equivalent of dividing the number by 8. Let's now solve the following bit shift operator problems. So for question A, we've got the number 14 and we shift it one bit to the left, so we are multiplying that number by 2. So the answer to that is 28. For B, we're now shifting 14 2 bits to the left, so we're multiplying 14 by 4, which is now 56. For C, we're shifting 14 1 bit to the right, so therefore we're halving the number, so that now gives us 7. And for D, we have 7 and we're shifting it 1 bit to the right, so we're halving it, but we're rounding down, so we're truncating. So 7 divided by 2 is 3.5, but we only take the whole part of that number, so we truncate it. So now that value is 3.